That is surface area. Under surface area then. The basic gist, the non-fair surface area. This is not a good example of surface area, but I guess it is. Oh wait, let's be making that. No, I want that box. Is there a box? When you talk about surface area is not a pleasant thing per se. Surface area is simply, though, the area of all sides added together. It's actually a little more complicated than volume is just with what you have to do for that. So let's say I've got this. Let's say I've got this box here, and we'll do a little three-dimensional representation of that. Here's the, doesn't matter what we call the front. We can draw it on a smaller scale. Okay. When you do surface area, okay, the basic gist is that you need to, first of all, figure out how many sides you have. This is not something you want to rush through. Okay? Let's say this, let's make it easy. What do you suppose? Let's guesstimate this. Let's say this box is 5 inches tall by probably 7 inches wide by, do you think that's a foot? Nope. Let's go 10 inches. 10 inches this way. That's all the dimensions you need to find the surface area of that. And really what you want to do is think about if you were to cut this up, you know, we have what's called a net. And it's not a net funicello. Anybody know a net funicello? Ever heard of a net funicello? This one I said doesn't make a good box because it's got a couple extra pieces to it. What you're looking for when you do surface area is basically this. And I need which would lead one to ask, how many boxes do you think Amazon goes through in any given day? Gotta be 14. 14? Yeah. 14 is a good guess. I think it may be a touch low. What I need here is this.
The Amazon numbers?
In one day,
Well, they had a banner day last day, didn't they, or?
they
In
did,
one day, how many boxes did they send out? 24 hours. 24 hours.
what do you think it would be?
20,000?
Oh, 20,000? Oh, I'll bet they're in the millions.
Peter has 14.
I'll bet they're in millions, maybe billions.
Can you Google something like that?
I just wasn't. I should have been a little more prepared for that. Hold on.
Let me know.
I would probably figure it out. I'll let you know. So here's the gist of that. Children. Oh, something just like that.
No, it's not 84.
See the plate. What? Move this stuff down. What happened to this sound? There's two pieces. Okay. back to the big books here. What you've got is this. We need to find the area of all the sides of this box, which means you kind of need to think about it if you unraveled it, what it would look like. So what you have is this. Mr. Amazon. Too much stuff. It's like going to Menards. You can't get that from my website. Okay, you've got a front right here. Understand that? The beauty of this, though, is here's my front. What do you notice about the front? There's another exact same size one on the back. So when you find one area, you've actually found two of them. You've got a front and a back. This thing, if we're all in agreement here, this has 6 sides to it. 1, 2, 3, 4, 5, 6. And what is the area of the front? It's a rectangle that looks like this, and its area is 5 times 7, which is 35. And you've got a back that's the exact same rectangle. It's also going to be 35. So there's our front. Take care of those two. Then we've got this, which is the right side. And just like on the right side, there is another identical left side exactly like it, those two sides. So we've got a right side we'll abbreviate as RS and a left side as RS. What are the dimensions of that? It's a little bigger rectangle than the front. It is 10 times 5. It's 5 high because this 5 goes all the way around. This 10 is all the lines that are that way. This 7 is all those lines. So it is what? 10 times 5, which is 2 50s. And then what's left is right, this top and the bottom, which again are identical to themselves. If it's a rectangular prism, they're going to be identical. And the top is the widest, it's the biggest rectangle there. It is this 7 times that 10. The top is 70, and the bottom is also 70. And you end up with, what? 70 plus 100 plus 140, 170 plus 140. The total surface area of that is 310 inches squared. Now when or why would you ever, did I get that right? Yeah. Why or when would you ever need to know that? What is surface area good for? Well, with the Christmas season coming up here, Peter. Yes? No, not Christmas tree. You put a Christmas tree in a box and give it to somebody? Kelsey? Yes, but that's not what you know, see, you're thinking the selfish way. If you're giving somebody a present, Gary.
You have to know how much wrapping paper?
Exactly. And wrapping paper, if you look on the box, it'll tell you, I believe, how many square inches. If you needed to wrap this box, you're going to have to get a roll of wrapping paper that has at least 310 square inches in it to fit around that box. Or the box company that was ordering the cardboard would have to order 310 square inches. I mean, it has to be cut or whatever, but that's how much total product they would have in making this box, 310 square inches. Other places where surface area comes into play, well, area, I guess surface area, I don't know what else you would do. I mean, there's a few other things. Wallpaper, yes, but wallpaper you wouldn't, I mean, wallpaper would be good, but you'd exclude the ceiling and the floor. You're doing all 4 walls, so you have to be careful with what you're doing there. Now, that is, and I don't think this is the first time we've done surface area, has it?
Yeah.
Oh, maybe it is. Now, they get a little more complex, but it's the same thing we just talked about with volume, you just have to kind of visualize. If you have a shape that looks like this, here's your chance to start drawing these again, Christian.
This team looked amazing.
I know. If you've got a shape like this, you have to be able to think about what the net, which means what, if you had a box like that and you unfolded it, you have to be able to think about what the sides that you can't see would also look like. Because you've got this side back here that you can't see. that goes up there. Okay, so if I were drawing, first of all, how many sides? If I'm doing the let's make really easy numbers. Let's make this 2, 2, 2, 2. This would actually be 4 and 4, because that's what it could be. If I were drawing, first of all, how many sides? Question mark. How many sides does that shape have? Well, if you want to label them, you could think the only two that you have that are probably exactly alike are the two bases. You got that one and this bottom L that's the same. And maybe it's a good idea for you just to draw that out. You've got a top, yuck. You've got a top, yuck. Over here. You've got a top that looks like what? It's that L shape, like this. And a bottom that's identical to it, right? You got the top that's up here, the bottom that looks like it. And then how many more rectangles would make up that shape? Let's make it too high. You've got this one, here's 1. Here is 2. Here is 3. Here is 4. And then you've got this backside here, which is 5, and then this backside here that you can't see, which is 6. So you're going to have 6 more shapes you have to find the area of. And it's probably a good idea for you to draw them and maybe mark them as you do them. What would be the area of this shape right here? Let's call that, I don't know, front. What's the area of that? It's 2 times 2, which is 4. Then you've got the area of this little piece right here, which is 2 times 2, 4. Then you got the area of this little piece right here, which is 2 times 2. And you got the area of this right here, which is 2 times 2, which is 4. We're going to run out of 4s here. What about this backside here that you can't see?
8.
Yeah, it's going to be 4, because I know it's 4 from here to here times 2. It's 8. What about this backside here that you can't see? Again, it's 4 times 2, 8. Now, what about the top and the bottom? It is 4 times 2. Let's draw this. 4 times 2 would give you this chunk right here. That's 8. What is this little piece from here to here? Right, 2 times 2 is 4. So the top is 12, and the bottom is 12. Add all of them together, you're going to get what? 12 and 8 is 20, 12 and 8 is 40, 40 and 16 is, I'm guessing it's going to be 56 inches squared. But total surface area has to be all of the areas of all of the sides added together. Does that sound like a winner? I don't think. Now, one additional thing there is this, write this down, blank piece of paper. Blank piece of paper. You need to know this because this will come up quite often. Usually this gets abbreviated as just LA, lateral surface area. And what that is somebody said wallpapering. For wallpapering, you would do the lateral surface area. It is the same as surface area without the top and the bottom. Well, let's just call it without the bases. Remember that whole loaf of bread thing? Usually that's the top and the bottom. Okay? In other words, if you had my room here, if I asked you for the lateral surface area of my classroom, you would just do the areas of all the walls, no bottom, no top. No wall, no ceiling, no floor. And that's usually what they'll ask you for. If you've got a room, if you have a room like this, so here's a window. See if I show you a nice little window. you wouldn't have to paint. Here's a doorway. Like drawing class. You know, if you were asked to find the lateral surface area of this room, you would just do the sides of the walls and add those together. Matter of fact, there's a problem in the book that gives you this, the lateral surface area of a tissue box. And the tissue box looks like this. Here's my tissue box. Tissues in it. Of 9, 5, and 4. If you're asked to find the lateral surface area of that tissue box, you would find the area of the front, this piece here, which is 9 times 4, and the back, which is also 36. And then you'd find the area of the right side, which is 20, and the left side back here, which is 20, and that would be it. No top, no bottom, just the area of the stuff that surrounds it. And it's 56 and 56, like 112. Lateral surface area is just the area of the sides. Okay. Total surface area, if they just ask you for surface area, they mean total, which would mean you have to add this. But if they ask you just for lateral surface area, that means just the sides. Isn't that probably the most exciting thing